Now we will see a problem based on Pickering governor. Now let's consider this problem. A gramophone is driven by a Pickering governor. The mass of each disc attached to the center of the leaf spring is 20 gram. So the mass is 20 gram. M equals to 20 gram, the given data. Each spring has 5 mm wide and 0.125 mm thick. So this is the cross section of a spring, which is 5 mm wide and 0.125 mm thick. Let B is the width of the spring, which is 5 mm, and T is the thickness of a spring, so that is 1.125 mm. The effective length of a spring is L, is 40 mm. The distance from the spindle axis to the center of gravity of the mass when the governor is in rest is 10 mm. So A is given as 10 mm. Find the speed of the turntable when the sleeve has a rise of 0.8 mm and the ratio of the governor speed to the turntable speed is 10.5. Governor speed to the turntable speed, this ratio is 10.5, and the modulus of elasticity is E equals to 210 kilonewton per mm square. Now using this data equals to 210 kilonewton per mm square. Using this data, first we will determine the moment of inertia, area moment of inertia of spring Pt cube by 12. Okay, here B is 5 mm and T is 0.125 mm. So it's cube divided by 12. So finally, its value comes 0.8 into 10 raised to minus 3 mm to the power 4. Then the effective length of a spring is 80 mm. And when the sleeve is risen by 0.8 mm, then the length we will use in the calculations becomes 40 minus 0.8 mm, because we have to find the turntable speed when the sleeve has risen by 0.8 mm. So the effective length will change from 40. The effective length will decrease because of this lift of the sleeve by that lift amount, that is 39.2 mm. So this is the value. Now we know that the relationship between the L and deflection delta and sleeve lift lambda and delta. So we can easily find the value of delta from this relation. This lambda equals to 2.54 into delta square by L. So lambda equals to 2.4 into delta square by L. Here we will take this L, which is after rising of the leaf. Lambda is given 0.8, 2.4 into delta square by 39.2. The value of delta using this relation we can calculate as 3.65 mm. Okay, this is the value of. Now We can determine value of delta using this relation also. Delta is equals to m omega square a plus delta into L cube into 192 EI. So using this relation, we can find the value of delta, but we know the value of delta. By substituting this value, we will find the value of unknown, which is omega from this relation. So I will take this equation with me. Copy. If I substitute the values here, delta is 3.65, mass is 20 grams, 20 into 10 raised to minus 3, omega square the known, a 10 mm and delta 3.65 L. We will use this length L is 39.2 divided by 192 E to 10 raised to 3 Newton per mm square into 0.8 to 10 raised to minus 3 mm to the power 4. So it is in Newton per mm square, is mm to the power 4. These two units are in mm. L is in mm. Okay, so all the length units are in mm. We'll get the value of omega by solving this relation as 2.675 radians per second. And we can convert this value in n using finally the relation of n. You can find 25.5 RPM. 25.5 RPM. Okay. So this is the speed of governor. Now we have given here that the ratio of speed of turntable when the sleeve is raised, the ratio of governor speed to the turntable speed is 10.5. We can use this data, the speed of governor divided by speed of turntable equals to 10.5. So we can find the value of speed of turntable equals to 25.5 divided by 10.5. 25.5 divided by 10.5 equals to 2.43 RPM. 2.43 RPM. So in this manner, we can solve the problems based on the Pickering governor. And we also see here that the Pickering governor is used in old gramophones. So these are the all spring-loaded type governors we covered in the sessions. If you have any doubt or query related to these topics, you can send your doubts or queries on the numbers given below. Thank you.